Hi y'all, today we're learning about solving logarithmic equations. So logarithmic equation, any equation that has a logarithm in it, it might have multiple logarithms in it. So we're learning like a new rule, which is that the log is the inverse of the exponent, which we already knew. So we're gonna use an exponent to get rid of it. So the steps are like this. Number one, the first thing we're gonna do is isolate the log, right? So we're gonna isolate that log. Then we're going to get rid of it by exponentiating. I don't know if that's a real word. I might have made that up. And then number three is we're going to solve it. Right. So those are the three steps that we're going to follow. And this is particularly when there is one logarithm in the problem. Right. So if our problem looks like this, where we have just one log, we are going to get it by itself, right? So here's log base 3. It applies to everything in the parentheses. So I'm going to get that by itself. So I'm going to get rid of this -3 by adding 3 on both sides. So I get log base 3, 2x minus 1 equals 4. Okay, so that is our step 1, right? So step 2 is the new rule, sort of, which is exponentiating. That's the word that I'm using, which basically says that if you have a base of 3, then you can get rid of it by doing this entire thing 3 to the power of all of this log. And that's going to cancel the log base and the exponent and just drop out what is left there, right? But you have to be careful because you can't just do it to one side. I'm going to erase this really fast. You can't just do it to one side. You have to obviously do it to both sides since it's an equation. So you're doing 3 to the power of this side equals 3 to the power of that side. So the 3 and the log would cancel and leave 2x minus 1 equals 3 to the power of 4, which is 3 times 3 times 3 times 3, 81. And we're going to go ahead and that's my second step, is that exponentiate step. And then third step, just solve like normal. So 2x equals 82, divide by 2, we get x equals 41. We can quickly check just by plugging into our calculators. So if you're using Desmos, we're just going to plug in -3 plus log base 3 of 2 times 41 minus 1. We should get +1, which we do, which is awesome. There. So we know that 41 is our correct answer. If you wanted to do this on the graphing calculator, I'll just throw this plug in here. If we have x here, like this, we should see the log equation, and we want to know where this side of the equation equals 1. So I'm going to put in here y equals 1. And we're going to see there's two lines. I see they're starting to come together over here, and I see that they actually come together at x equals 41. Right, so if you had a graphing calculator, you could solve this problem like that. Cool, let's do another one. So here we see basically the exact same problem, right? We still have the -3, it still equals 1, but this time it's -1. But differently, we have a natural log. So we're still going to get that natural log by itself, right? I'm still going to, first things first, add 3 on both sides. I get natural log of 2x minus 1 equals 2. Right? And then I have to think, what is the base of the natural log? The base of the natural log is e. So when I exponentiate, I'm going to do e to the power of this is equal to e to the power of that. Right? So e to the power of this is cancels with the log, leaves me with 2x minus 1 equals e squared. Remember, e squared is just a number, so we can go to our calculators and calculate e squared, 7.38. So I'm going to add 1 to that number. So I'm adding 1. I get 2x equals 8.389, etc. And then I'm going to go ahead and take that and divide by 2. and I get x equals 4.195. Use 3 decimal places there. Right. If I was to take that number and plug it in, so -3 plus the natural log of 2 times 4.195 minus 1, I should get something roughly similar to -1. I'm not getting exactly the same answer since I didn't type in this entire number, right, since the number is rational. So that is how I would do this if there is just one log in the problem. If there are multiple logarithms, it follows generally the same trend, right? The first thing we're going to do is consolidate. So I mean like combine the logs into one log. Combine them into one log so we have a problem that's basically like the last one. And then we're going to exponentiate and solve. So we're going to be using our log properties for this problem here. So go ahead and take a moment to write this down. So I notice that I have log base 2 of x plus 2 minus log base 2 of x minus 1. So I know that anytime I have the log with the same base, right, then I know that I can combine them. And I know if it's subtraction, then these things are going to be divided, right? So I know it's divided. So I'm going to have log base 2 of x plus 2 over x minus 1. Like that, right? Because I'm taking this thing, I'm dividing it by that thing over there. And this whole thing is equal to 3, right? So now I have one log, just like our previous problems, and I'm going to exponentiate. So this has a base of 2. So I do 2 to the power of that, 2 to the power of this. It's going to give me x plus 2 over x minus 1 equals 2 to the third, which is 8. And then from there, I'm just going to solve. So I'm going to multiply both sides by x minus 1. Leaves me with x plus 2 equals 8x minus 8. Don't forget to distribute, common problem. Go ahead and subtract this x over there. Add 8 over here. We get 10 equals 7x. Dividing by 7, we get 10 sevenths equals x. Just like that. If I wanted to check my thinking here, I again could plug it in my calculator. Oops. We'll do log base 2 of x plus 2 minus log base 2 of x minus 1. Right? And then I could put in just y equals 3 here. And I can click on this guy here, and I see that it's 14 or 1.429. I think that's probably the same as 10 over 7, but we'll check. 4.129 for sure. So I got the correct answer there, and I can continue on my way. Cool. Let's try one more here. So we notice that I have a natural log, a natural log, and a natural log. So I am trying to combine these ones into one log. So I have the natural log. I see that it's addition. So I know that addition is going to be multiplication. So x plus 2 times x equals ln natural log of 8. Right? I have just a log here and a log here. So I can go ahead and exponentiate. Remember, I have a base of e. So I have e to the power of, e to the power of. It's going to cancel here and leave me with x plus 2 times x equals, both of those cancel as well, equals 8. I'm going to go ahead and distribute. So I have x squared plus 2x equals 8. Moving that 8 to the other side, x squared plus 2x minus 8 equals 0. I can factor. x minus plus 4, x minus 2. So I'd have x equals -4 and x equals 2. Okay, so these are my two answers. You might be wondering, like, how am I going to get two answers? If you put this in your calculator, you can see ln natural log of x plus 2 plus the natural log of x, right? And then we have on this side the natural log of 8. Right? I'm going to put y equals. Right? We can see, there's actually only one solution here. Right? Only one solution, +2. Right? So we have to ask ourselves, what happened? Why is -4 appear to be extraneous? Right? Think about what would happen if I put -4 in here. If I tried to do the natural log of -4 plus 2, natural log -4 plus 2, right? Then I would get the natural log of -2. I have e to the power of what would give me -2? There's nothing. We can't do the log of a negative number. And so therefore, this is extraneous. There is only one solution, and that solution is 2. All right. So always good to check our answers there. If you can't do these things that we're talking about here, you can always use your calculator, right? So if nothing else works, graph it and see the solutions. Right, so today we are exponentiating. Ask whatever questions you have. I'm excited to see you.